Hi everyone, I am J.UMAMAGESWARAN. I am working as an assistant professor in RMK Engineering College, and today I am going to speak, I am going to tell about computer graphics. Under the computer graphics, what graphics is all about and what we are going to discuss. I am here only to say about the basics, what graphics is all about. So first we will start with what a 2D graphics and algorithm is all about. So the agenda of today's session, I am going to tell overview of a 2D graphics algorithm. First we will see what is output primitive, which is very essential for to know about the computer graphics, and later on we will be discussing about the line drawing algorithm. Under the line drawing algorithm we have a various algorithm, but there is a two algorithm which is very successful algorithm. One is DDA and another one is Bresenham's line drawing algorithm. We have a lot of version for line drawing algorithm, but these two are major and very important algorithms for drawing a line. And after that we will be discussing about the circle drawing algorithm, and followed by the ellipse drawing algorithm, and we will be discussing more about what is 2D geometric transformation and 2D clipping. First we will just move on to an output primitive. What is output primitive? So output primitive, any geometrical shapes. Simply we can say that we can define, like output primitive can be defined as a basic geometrical structure, such as even a point I can say as an output primitive, or line, circle, ellipse, rectangle, square, any basic geometrical shape we can define it as an output primitive. So now I need to know how to draw a point, how to draw a line, how to draw a circle, how to draw an ellipse. If I know the basic geometrical shape, if I know how to draw these shapes, so that I can able to do some complex animations. So now we will just move on to the next topic about a line drawing algorithm. As I told you, in order to draw a line, we have various algorithms, lot of line drawing algorithm, but the two algorithm which is more successful, and a lot of people they prefer this algorithm for drawing a line. One is DDA line drawing algorithm, and another one is Bresenham's line drawing algorithm. Why we have a DDA and why we need to go for Bresenham? You might be having a question. So first, the DDA line drawing algorithm, what it does is we can draw a line more faster rather than any other algorithm, because we are not going to use any operators over there. So simply we are going to calculate the x and y interval, and we are going to increment one by one towards the another endpoint. So what do you mean by line? What we are supposed to know about to draw a line drawing algorithm? First, in order to draw a line, we need to describe an input. So what input that we have to describe for a line? So for drawing a line, we need to describe two input called two endpoint, such as x0 y0 and x1 y1. So we have two endpoint, and in between these two endpoint we have to plot a pixel. For plotting a pixel, we are using DDA and Bresenham's line drawing algorithm. So DDA will generate a line more faster than any other algorithm, but Bresenham's will give an accurate results. Accuracy will be maintained in a Bresenham's line drawing algorithm, because we are going to find the x and y value for each and every pixel. So next we will move on to the topic called a circle drawing algorithm. So what is circle drawing algorithm? Any algorithm, first we need to describe an input. For drawing a line, we have to define a two endpoint, x1 y1, x2 y2. For drawing a circle, we have to define an input point, which is nothing here as center point, xc, yc, and the radius. So here for drawing a circle, we have a algorithm called midpoint circle drawing algorithm, which is most popular algorithm to draw a circle. So just we will discuss more about this algorithm in the upcoming session. Now I am here just to tell you about what are the things what are the algorithm we will be using under the 2D graphics. So next one is about midpoint ellipse drawing algorithm. Same like I told you, for defining any object we need to know input. So for drawing an ellipse, we have to define an input with the center point, and here for circle we will be using only one radius to draw a circle. But here for drawing an ellipse, in the input we have to define two radius. One is semi-major axis radius and another one is semi-minor axis. So along with the center point we have to define this two radius to plot an ellipse. Then coming to the 2D geometric transformation. Now using a DDA line drawing, a Bresenham's and circle drawing and ellipse drawing algorithm, I know how to draw the basic geometrical shapes. So as I told you, the definition of output primitive. Now I know all the objects, I know how to draw all the objects, but now I want to do some animations. So what I need to do? So what techniques that I need to know? So for that we are moving to the topic called 2D geometric transformation. So under 2D geometric transformations we have various transformations such as translations, rotation and scaling, and you have some other transformation called reflection and shading. So what this all about? So translation, I want to move an object. I know a circle, how to draw a circle. Now I want to perform an animation with the circle, which means I need to move a circle from one place to another place. That can be done by using a translation. And I want to increase the circle size, or I want to reduce the circle size. So I can do it by using scaling, and I can go for a rotation by moving an object with respect to some angular value. I want to change the shape of the circle. That can be done by using a shading, and I want to give a mirror image of an object, so I can do with a reflection. So now I can perform a lot of animations by using a 2D geometric transformation. So that's why I'm just telling this 2D geometric transformation is very essential for doing an animated work. So but anyway, whatever the things that you want to describe in a computer, you need to know some basic stuff like basic line drawing, circle drawing and ellipse drawing. That is something fundamentals about all about 2D graphics. So followed by we will be discussing about 2D clipping. So from this slide, if you can find, I have represented something called a point clipping and string clipping, or else we can say it as a text clipping. Point clipping, this is something where I can say it as a clipping boundary, and this is something I can say as XW min and XW max, and you have towards on Y coordinate you have a YW min and YW max. So now I am just checking this point, which means the X and Y location of that point, whether the point which lies inside the window or outside the window, by using this boundary condition. For example, I will be using this two line to ensure whether the point lies inside or outside the clipping window. So for example, the X should be less than XW min, and it should be it should be greater than the XW min, and it should be less than the XW max. Similarly, the Y value should be the Y value of the point should be greater than the minimum and lesser than the maximum of window size. So then the point which lies inside the window. So that is the concept of clipping, which means as simple I can tell you a small story. Let me take a camera, and right now I can view the entire item which is sitting in front of me. So I can see the number of students sitting inside me, in front of me. I can see the fans, tube lights, bench and bags, everything. But now just assume that I have a camera. I'm just facing the camera towards you, and I'm just trying to focus only with the center bench. So which means I can see the entire object which lies inside the class through my eye, but I can't focus the entire thing on my camera screen. So that is the concept of clipping. Only the object which lies inside the camera screen can store, and outside the camera screen cannot be stored on the memory. So that's the concept of clipping. Thank you guys. We'll just in detail we'll discuss more about the 2D graphics in upcoming session. Thank you.